cards, you'll see all of this fun stuff. Another way to get some margin would be, especially when we're talking about international circuits, is to be more efficient using those circuits. So not to provide circuit switched DS0 service, which is what we normally do, but instead provide voice over IP service, hopefully transparently to the user. And then this reseller doesn't have to lease as many channels or DS0 channels or trunks, if you want to call them that, from the carrier, so hopefully they can make a bit more money. Bypassing a domestic local exchange carrier might be another way that ends up being cheaper. As we mentioned in Chapter 1, the idea here is that the LEC adds a per minute charge for access to any long distance phone call, and it's usually 1 or 2 or 3 cents a minute. Some places it's up to 7 cents a minute. The idea is that we can not use the LEC for access. We could use a dedicated T1, or we could use a CLEC and just bypass them and then do voice over IP, and this way we don't have to pay their switched access charge for every phone call, which could result in quite a significant savings if we're talking about an organization that has phone bills measured in the millions of dollars per year. Now all of this is fine, but the question is, what does it sound like to the listener on the far end? And when we want to start investigating what sort of voice quality we're going to get, the very first thing we have to look at is what is the underlying IP network service that's being used to move these IP packets that have coded voice in them. And the whole range of possibilities exists. One possibility would be that we have dedicated capacity, whether it's like a dark fiber where you put your own lasers and flashlights on and on to represent ones and zeros, or it's a dedicated DS3 rate channel, 45 megabits per second, that they're leasing from somebody. The idea in both cases is we have dedicated capacity, and we, the carrier, the reseller, as I was talking about, are the only ones who are using this capacity. And so therefore we can be quite careful and do traffic engineering, and we can end up with quality that sounds exactly the same as a regular circuit switch phone call. But that's pretty expensive. And we might start being tempted as a carrier not to use dedicated capacity for our trunks, but instead use a packet network service from some other carrier in order to move those IP packets back and forth. Now, that could be an IP VPN service, and as we mentioned in Chapter 1, the idea here is essentially that this is a carefully controlled IP network, and it was designed for data communications, but now we as the reseller are going to get service from this IP VPN network in order to move our IP packets around. And since this is shared capacity, even though it's secure, it's still shared underlying it, it's going to end up being cheaper. The problem with that is there are no guarantees as to delay on an IP VPN network. So it'll probably sound good, but we can't guarantee that. If they want to get really cheap, then they could use the internet to connect their point of presence on the island of Guadeloupe to their point of presence in Florida. And who knows what paths the packets are going to take and how long they're going to take and how many of them are going to get dropped. The internet is you pays your money, you takes your chances. And so if you have the unfortunate circumstance of having bought a prepaid phone card from a company that takes your phone call, puts it in packets, and sends them over the internet to a gateway to turn it back into a regular phone call somewhere else, who knows what kind of quality you're going to get. It might be fine in the middle of the night, but I wouldn't rely on this for business quality communications at 9:30 a.m., that's for sure. What we would really like to get to is native voice over IP carriers. And this is a carrier that's deployed equipment like routers, but they're able to guarantee the delays and the quality going from A to B across their network. And by being able to do that, then we can guarantee what it's going to sound like. Every carrier is going to deploy these, and there are a few deployed now. But most of the time when we're talking about long-distance IP communications, it's one of the three previous ones we mentioned. Over dedicated capacity, over a data network, which is carefully controlled, usually called an IP VPN service, or over the internet. And the middle two don't give you any guaranteed quality of service. Let's talk about this one a little more. I find this story almost humorous because of the huge amount of hype that attended the announcement of long-distance voice over the internet from your cable company, and just the radical amounts of misinformation or missed information that was not reported, along with these sort of cheerleading type stories that you would read in USA Today. Now the idea here is that you have a broadband cable modem or DSL modem access to the internet, and that the internet service provider is going to build a high quality access network in the metropolitan area, and then they will undertake to deliver your phone calls to somebody with a regular phone at the far end. In theory, what's going to happen is that you'll get a little adapter box and you'll plug your regular telephone into that along with your computer. That plugs into your cable modem, and then that goes over the internet service provider, the cable company in this example, their access network. And then they'll take your IP packets with voice in them and give those to a long-distance IP network that will deliver them to the far end to a gateway to turn it into a regular phone call to deliver to somebody with a regular phone on the far end. And this is going to be cheaper, mainly because there is no regulation, so therefore no universal service fees. That's not going to last for very long. Another reason why it might be cheaper is that we are bypassing the local exchange carrier on the access part of this story, and statistical multiplexing, as we discussed before. But what about 911 service? And there are a couple of aspects to that. First of all, when you sign up for this internet telephony over cable TV service, in the fine print of the contract, are you going to have to agree that this is a secondary telephone service, and you will also maintain a regular POTS line from the phone company for 911 purposes? Because we've had a long time to figure out how to build equipment so that when you pick up your regular phone and dial 911, you're connected to a public service answering point, and your street address and name come up on a screen in front of the person you're talking to. It's not so clear whether we can do that, first of all, over cable TV, and then if people are doing voice over IP. And we will figure these questions out, but at the beginning of the story, are you going to be able to have 911 service? That would be a question I'd want to know, because if the story with this is that it's supposed to be cheaper and save money, but it turns out you have to agree this is a secondary service and still maintain your primary phone line from the phone company. Now, the other aspect of 911, of course, is being able to connect from your location to the public service answering point, to be able to actually communicate information, like talk to them. Now we start to think of reliability of access networks. How reliable is Ma Bell's telephone access network? Well, that's pretty reliable stuff. It's real rare that your telephone stops working. Where I live, we had an ice storm and we were without power for 11 days. No power, but the phone kept working perfectly the whole time. No interruptions. Now you start thinking, how often does a cable TV system go on the fritz? Well, that happens way more often than Ma Bell's access network. So you start to think, yeah, okay, I've got an older person in my home, 911 is important for heart attack purposes, and I'm going to run my 911 service over cable TV. Yeah, okay, sure, go ahead, do that. Hope it works. A thorny issue is the question of how do you connect all of the telephones in your house to this adapter? Because remember, the idea with voice over cable TV